Hello everybody, hopefully I've learned my lesson from last time on making this full screen. So we are going to be on page 3 today. And page 3 is going to be prime factorization. I know that's a lot of letters, prime factorization, but we'll figure it out. Remember that goes across the 2-page spread. All right, I want you to start by writing, leave some space over here, but just write the word factor. And take a second to think about what factors are. Factors are the numbers we multiply together to get a product, right? So this is the root of what we're doing is we are finding factors. When we find the factors of a number, we say that we are factorizing it, or the factorization of a number is finding its factors. So this is just a fancy word for saying finding factors, or listing factors, or identifying factors, whatever you want to say. So then the little bit that we're going to add to it now from what we did yesterday is prime factorization. Prime numbers are numbers that have exactly 2 factors, one and itself. So our definition right here numbers with exactly 2 factors, one and itself. So some examples that come to mind would be 2, 3, 5, 7, 11, ... It goes on and on and on. Those are prime numbers. So when we're finding prime, when we're doing prime factorization, we're finding factors, but we're specifically focused on finding prime factors. So prime factorization altogether as a total word means finding the prime factors of a number or the product. Remember, the product is the big number. So we have a strategy that we use when we do this, which is called a factor tree. But let's just start by picking a number like we did 10 before. So I'll say our product that we're going to use is 10. When we're finding the prime factors, we're not, well, let's just say, sorry, I know I'm talking all over the place. Okay, we know that the factors of 10 are 1, 2, 5, 10, right? Because we have 1 times 10 and 2 times 5. What we want to get down to is making a problem that equals 10 that uses only prime numbers. Now, 1 is not a prime number. Think about why that might be for a second. 1 is not a prime number because 1 only has 1 factor. But a prime number has exactly 2 factors. So 1 cannot be a prime number. So out of the list of factors, 1, 2, 5, and 10, I can eliminate 1. So now with the numbers I have left, I'm looking for which ones are prime numbers. 2 is a prime number, 5 is a prime number, 10 is not a prime number because we can make 10, it has more than 2 factors. So 10 is not a prime number. So the prime factorization of 10 is 2 times 5 equals 10 because both of these are both prime numbers. Another example, let me do one from your book. The product in this case is 9. Okay, the factors of 9 are 1 times 9, 3 times 3. We know that 1 is not a factor, or 1 is not a prime number. 9 is not a prime number because right here I just listed that it has another factor. So 3 times 3 is our prime factorization. But we learned before the quiz earlier in this chapter that we have a different way to represent this when we have the same number multiplied by itself. And that's exponents. So 3 to the second power, because I have 2 3s. 3 to the second power is 9. That is the prime factorization of 9. So I'm going to have you try a few of these, and then we will go from there on another strategy.